This is section 3.3, proofs with parallel lines. So in previous lessons, we've learned about different kinds of pairs of angles, whether they're alternate exterior, alternate interior, consecutive interior, or corresponding. And then we learned that if two lines are parallel, they have a special relationship. So whether that means they're congruent or they add up to 180. Now in this lesson, what we're going to do is we're going to flip that and we're going to say, okay, what do these angles have to be in order for these lines to be parallel? So we're going to be talking about the converses today. So the corresponding angles converse says if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So for example, we want to find the value of x that makes m and n parallel. Well, we know if m and n are parallel, then these two corresponding angles have to be congruent. So I want to find the value of x that makes them congruent. So I'm going to set up my equation, 3x plus 5, and I want it to be equal to 65. And then I'm going to go ahead and solve. 3x equals 60, divided by 3. So x is equal to 20. So if x is equal to 20, then lines m and n are parallel. So we use the converse with the corresponding angles. You can use the converse for the alternate interior angles, alternate exterior angles, and consecutive interior angles. So let's do a proof. We're given that angle 4 is congruent to angle 5, and we want to prove that G is parallel to H. All right, so we know right off the bat that angle 4 is congruent to angle 5 because that's given to us. Now, using the vertical angles congruence theorem, okay, so I want to think about vertical angles. I'm going to say that angle 1 is congruent to angle 4 because I know those are vertical angles. By the transitive property, I'm trying to combine lines 1 and 2 using the transitive property or substitution, and I'm going to say that angle 1 is congruent to angle 5. Now, angle 1 and angle 5 are corresponding angles, and if they're congruent, then we know that G has to be parallel to H. And then the last thing, the transitive property of parallel lines. So if two lines are parallel to the same line, then they're parallel to each other. So if P is parallel to Q and Q is parallel to R, then P has to be parallel to R.